thank you all for attending the breakfast presentation. It's my first time at Energy Disruptors and my first time in Calgary, even though I've spent a lot of time in Canada. So I appreciate you hearing me out, really, on the humble lithium-ion battery, which is a central pillar for the energy storage revolution. I'll explain in a second. We're just going to start with a video to take you back to 2016. So video play now, if possible.
To the whole village without ever having to run thousands of miles of high voltage cable all over the place. It's like what happened with landline phones versus cellular phones. In a lot of developed countries, they just didn't do the landline phones. They just went straight to cellular. We actually did the calculations to say, like, what would it take to transition the whole world to sustainable energy? What kind of throughput would you actually need? And you need 100 gigafactories. So
100 of these?
100 of these, yes.
That would make the United States...
No, the whole world.
The whole world?
The whole world. All energy.
That's it?
Yeah.
That sounds...
It's manageable.
That sounds manageable.
Yeah.
So
the gigafactory, when it's complete, will have the largest footprint of any building in the world.
Okay, all good on the video.
Levels, it could be as much as 15 million.
And so that's the gigafactory, the original supersized lithium-ion battery plant that is effectively going to become the engine of this energy transition. Basically, this was the first, really, of what we have now, 347, give or take, supersized battery plants in the world. So it started with that, and with Elon and J.B. Straubel deciding to put the entire battery industry under one roof, and then essentially to fuel electric vehicle growth and the start of energy storage as well. Recently, Elon came out with a number which actually is framing this presentation, and he said in a recent TED Talk that they expect at present to have to be fully sustainable for energy. You need 300 terawatt hours of batteries installed. So I've put some numbers to work out how big can this lithium-ion battery industry get to, and what are the realities and the impacts on the critical mineral supply chains that fuel it. This is the battery supply chain as we see it, right? It's really simple. So everything that I talk about, just bear these kind of core principles in mind. Of course, you've got mining. Canada is the home of mining, in my eyes, but it's actually the home of exploration of critical minerals rather than the production of them. So that's something to discuss. Next step is these minerals are being dug out of the ground, but they're actually made into specialty chemicals. They're not commodities, they're specialty chemicals. They're not easy, but it's not rocket science. So that's the next step, taking lithium out of the ground, turning it into lithium hydroxide or lithium carbonate that can be used in a battery. Not all lithium, not all cobalt, not all nickel can be used in a battery. So that's the chemical processing step. Same for the cathodes and anodes. And then once you've got these materials, got to your cathode anode stage, you go into a lithium-ion battery cell, the gigafactory. It's like a big printing press. And that's actually engineering, classic engineering and manufacturing. It's not chemical engineering. And of course, the electric vehicles they end up in. So there's a few things there to bear in mind. Number one is there's 3 elements to this supply chain. 3 different worlds. The mining guys are very different to the chemical guys, are very different to the manufacturing guys. And these worlds and countries and regions are all combining to a delicious moment, I would say, and I'll explain it in a minute. Where are we today for lithium-ion battery production? So this is forecasted supply, not demand, from us at Benchmark. We're bang in the middle here. You can see it 2022. It looks tiny. But the last 5 years, well, last 7 years since 2015, or 8 years now, the battery industry has grown an order of magnitude. So whilst it looks tiny now to where we're going, we've grown from batteries being made in buildings the size of probably the canteen area over there, to battery plants the size of football stadiums. And that's a massive shift for the raw material industry. It's gone from about 60 gigawatt hours to 600 gigawatt hours. It's pretty much exactly an order of magnitude when you look at the real numbers. But going forward, the challenge is even bigger, because you've got to scale these supply chains at a level and speed that we've never experienced before in any commodity, in any age, or the last sort of 200 years, let's say. So long-term, lithium-ion battery supply is being hamstrung from meeting demand. So I've taken the supply demand here in 5-year chunks out to 2040. The blue is the supply, the orange is demand. You can see this year, whilst we will have problems with tier 1 battery production getting into EVs, driven by the lack of raw material supply for everybody, the problems happen next decade. The really big, let's call it, raw material cliff edge or a great raw material disconnect, is what we like to use, happens 10 years from now. So what we do now defines the next, what happens the next decade and beyond. So how many gigafactories in the pipeline? I said 247. Actually, it is around that now. This number's 1 month old, and that's how many new battery plants have been put in the pipeline in the last month. The key is 242 of this number here are in China. The vast majority are in China. We have 32 now in Europe, actually, and then 23 in North America under construction. But it's a new phenomenon. It's the last 4 years. The active producing battery cells, apart from the gigafactory, are all in China. And you can see here where batteries are made. China's dominant position remains over the next 10 years, even though regions will start making their own battery cells. Just a fundamental here, if electric vehicles are lithium-ion batteries, then electric vehicles really should be mining. And certainly the way companies think about it. In 2015, these pies show the cost of a lithium-ion battery cell. 40% in 2015 of a battery cell was raw materials, minerals, metals, chemicals that go into make a battery. So before 2015, this pre-gigafactory era, battery makers, they could get their cobalt, they could get their graphite, lithium, manganese, and so on. There wasn't really any supply shocks, and so why do anything? I can get my raw materials, I can make my batteries, it's fine. Of course, it's a different world now. As this scale has happened in the industry, this gigafactory era has dawned on us, costs have dropped significantly from about $300 a kilowatt hour at cell level to now $115 to $120 a kilowatt hour. That means that the raw materials now are about 70 to 80% of the cost of a battery. Prices have shot up. People making these factories can't get the raw materials, can't get these critical minerals. So that's a bit of a shock to the system the last 2 years, let's say. So this is a realization for legacy automakers. So all those guys making the EVs, especially, not Tesla necessarily, because they've been built for this. The whole culture's been built to create a new industry. I'm talking about all the legacy automakers, whether it's in North America or Europe especially. This is the thought process they've gone through. So in 2015 to 2016, it was simply, well, electric vehicles are a thing of the future. It could be lithium-ion powered EVs. It could be hydrogen. Then what happened? Tesla and China surged. Lithium-ion powered EVs went through the roof. Number two, 2017 to 2018, they then thought, well, we need lithium-ion batteries. We accept the technology. But our suppliers ensure us there will be batteries available to make our EVs. What happens next? Automakers realize that's not happening, and they start building their own gigafactories. Number three, 2020 to 2021, then they said, well, we've got our battery supply by building gigafactories, and our raw materials guys assure us there will be supply of lithium, nickel, cobalt, graphite, manganese. What happens? Raw materials go through the roof. Price, supply's not there. They can't get their raw materials. And then where are we today? The automakers and governments now are saying, well, we need to build more mines. So what happens next? That's one to discuss later on. This is the supply chain as we stand today. Who controls from the supply chain globally, from mining to making batteries? Now, even though China does control the midstream and downstream, the red is China on this, by the way. China's got a very dominant position in making these specialty chemicals and making lithium-ion batteries, and as a result, it's got the biggest electric vehicle industry in the world. So that control of the midstream and downstream has given a dominant position in EVs. But China doesn't have the necessary resources at the quality and grade needed to make these. Canada does, Australia does, South America in some countries does. And so what happens then, about 10 years ago, Chinese companies start to invest in these resources. It started about 2012. Whereas in the West, we're still thinking, we're still dabbling. Automakers are giving some loans to companies. Automakers are saying, well, if you get to production, we'll then buy from you at this. But this is not good enough. It's not going to happen because money's needed to build the mines today. Otherwise, most of these car companies won't have a business. How many mines will we need? This is just a quick sketch. You Google this and benchmark and how many mines. There's a story where this kind of like graphic went everywhere. Loads more mines are needed. Effectively, the energy transition is mining, like full stop. Electric vehicles and battery is mining. And the money has to go to first building a sustainable base for what we're needed. And everything comes from that. This is the lithium price trend. So you can see, if you're a car maker or a battery maker, you kind of looked at that. They never believed it. All the way along that price chart, they never believed that prices would go up. They've never really gone up. There's a bit of a panic in 2018, that first bump you can see. And now they're accepting that deals are being done. They're accepting this $40,000 to $50,000 a ton range. They're like, well, we're happy with that for the next 2 years. 2 years ago, they wanted $15 a ton. It's ridiculous. It's so reactive. And those that react will be left empty-handed along this journey. Just talk about geopolitics a bit in the last 5 minutes. I would say since February last year, when the White House put out I think it was the American Jobs Act plan, I think that was the title of it, and they cited lithium-ion batteries as a core platform technology to invest and build new industries. That kind of started changing the whole narrative outside of China. The European Union has done a good job at focusing, I would say, industry on the upstream and the need for mining and getting these materials out of the ground. But when the White House talks about it, North America starts to move. Didn't move quick enough, really, and this Inflation Reduction Act has really, I was explaining to Nico yesterday, we were having a chat, and it's kind of lit a fire. I like that term. I think it was your term, wasn't it, Nico? Lit a fire under the industry. Doesn't mean that and by the way, this is money, let's say tax breaks going into every stage of the supply chain. It's a thought out process. Doesn't mean all these projects are going to be funded straight away. We need to talk about permitting. We need to treat these critical minerals that build the energy transition. You need to treat them separately, but at the same time with an ESG lens on it, but you need to treat them separately and special as the other mining and extractive industries. Then finally, this happens. Of course, we're in Canada. This is an interesting one. It's a bit of a surprise. From the industry I'm in, I've done critical minerals since 2006, just done this since I left uni, and I never saw governments doing deals with car companies. It might have happened in the oil industry, other industries, I don't know. But having your Prime Minister do deals with VW Mercedes and is very interesting. Again, setting the narrative, sending out the message, like the White House did on batteries, sending out the message that Canada is open for business. But if you don't match this with completely reinventing or revisiting, let's say, the permitting process, getting mines up and running quicker, and making sure that funding goes into these, then it's just not going to work. But the point here is Canada does have the potential to be the gatekeeper for North America's electric vehicle revolution. Those that control that mining and that chemical processing, step 1 and step 2, will control the sway of industrial power for this entire movement, for electric vehicles and energy storage systems. So to finish the last 3 minutes, I wanted to look at how do we get to, or can we get to 300 terawatt-hours of installed batteries? We could talk about battery tech and stuff afterwards on the panel and all of that. But just to kind of sketch this out, 300 terawatt-hours of installed batteries in EVs and in ESS, both NCM, LFP chemistries. Well, at the moment, just on a battery level, we would need to increase the pace of building gigafactories by 6 to 7 times in the next 10 years. So this is by 2032. If we hit 20 terawatt hours or 20,000 gigawatt hours of production of battery cells by 2022, you have 300 terawatt hours of installed capacity by 2050 net zero. That isn't going to happen. The good news is there's no blocker for it except for money, getting money into the supply chain and making sure we can put this tonnage of raw materials into the market to build those batteries. Key thing here is it takes 7 to 10 years to build a mine. It takes 24 months to build a battery plant. So we've got 10 years to actually build these mines and try and get even close to these numbers that I'm showing you here. So for lithium, 600,000 ton industry today, LCE, we need to go to about a 14 million ton industry. That's not crazy, right? That's the size of a large chemical industry. It's certainly not the size of hydrocarbons at all. So all of this is very doable. It's just having a strategy, and it's making sure investors don't argue about the next 500,000 tons. You go into like 10 million tons plus here, and that long-term perspective is needed if we're going to achieve what we need to achieve. Finally, some points to take away. How I think about this lithium-ion battery supply chain in this energy transition, in this net zero thing. So we won't be able to, well, we will be able to meet Elon's target of 300. We won't be able to do it by 2050. It's not what he said, to be fair. It was just what governments want. We can be fully sustainable. We can get that amount of batteries into the market by the mid-2060s at the pace we're going. That's a sensible target. There's not a shortage of critical minerals in the ground. The resources are already there and mapped out. You can look at, we're putting out a report on this where we'll just showcase that. The reserves need to be proved up, but that's a natural process anyway with the exploration of minerals and mining. There is a lack of willing capital. Money still doesn't quite get it, or if it gets it, it doesn't want to move. And it has to move in 500 million chunks. At the moment, money moves in 50 million chunks for this industry. If it moves in 500 million chunks, US dollars, then you start seeing movement. And finally, Canada, again, has the opportunity to fuel pretty much all of North America's ambitions here. Overall, the amount of money needed, $3 to $5 trillion. That includes people messing up, which a lot of money will be misallocated. The upside is that's only 5% of this energy transition tab. I'll leave you with that. I'm 6 seconds over. Thank you very much for your time.